All right, good morning, guys. Today we're going to be covering 8.10 equations of circles. Now, uniquely today, we're going to be covering circles that do not have their centers at the that do have their centers at the origin. So those are going to be the specific circles that we're going to be dealing with. Now, later on in this week, we're going to be covering 8.11, which is where we do not have our center at the origin of a coordinate plane. So those are going to be the two different lessons that we're going to be dealing with and the two different types of equations of circles that we'll be dealing with. Our learning target for today is I can write the equation of a circle and draw a circle given an equation. So with that being said, let's go ahead and get started. First off, an equation of a circle. A circle with a radius of 10 and a center at 0, 0 is shown on the coordinate grid below. So I can see that we have a center at 0, 0 right here at the origin. And if I just count from that origin, if I count out 10, I'll be at the edge of my circle here, meaning our radius is 10 units in length. So the first thing that we have is the equation of circles themselves. And the equation of circles that we'll be using is x minus the x value of the center of our circle squared plus y minus the y value of the center of our circle squared equals our radius squared. So this will be the equation of any circle that you come across. And for this equation here, it doesn't necessarily mean that your center needs to be 0, 0. Of course, these numbers can change and that center will move as well. It can be anywhere on the Cartesian plane, in fact. Now, they ask us a few questions to go along with this. They ask, is the point 6, 8 on the graph? So if I go ahead and I graph out the point 6, 8 from my origin, I can move to the right 6 and then move up 8. And it's right here. It's this point that looks like it could be on the graph. Now, if I'm not sure if it's on the graph or not, there is a way for us to check. But looking at this looks like it does fall on the graph perfectly, so I'm going to go ahead and say yes. And then if I check the point -6, -8, well, since the center's the same, it should also fall perfectly on our circle as well. -6, -8 does work perfectly fine as well. So, if we're ever not sure, if it gets really close, then what we can do is we can always plug in our values, the point, into the equation of our circle and solve. Another way that we can go ahead and find the radius, if we're given just the circle and some points, is to use Pythagorean's theorem. Again, Pythagorean's theorem will allow us to solve for the radius using a squared plus b squared equals c squared. So if I were to make a right triangle with the point -6, -8 and the origin, what we would see is that we would be able to use Pythagorean's theorem. We'd have 6 squared, 8 squared, and the radius squared. So 8 squared plus 6 squared equals r squared. 8 squared is 64. 6 squared is 36. 64 plus 36 is 100. The square root of 100 is 10, meaning that our radius is 10, which is what they told us already. So I know that since they're telling me that it gives me a radius of 10 in this case, and that we already know the radius is 10, that this point and 6, 8 both would fall perfectly on the circle itself. Which leads us to the equation of this circle. Well, if I plug in my center as 0, 0, and my radius as 10, I'd be left with x squared plus y squared equals 100. All right, let's go ahead and try out another one. So, for these two equations, we want to find the radius of the circle. So I have x squared plus y squared equals 16. Now, if we recall, the equation of our circle is just x minus the x value of our center squared plus y minus the y value of our center squared equals r squared. So if I want to solve for the radius, I just set r squared equal to the constant. So I say 16 equals r squared. Solving for r, I take the square root of both sides to cancel out the square. The square root of 16 will leave us with positive 4. So the radius of this first circle is 4. Doing the same thing with our second circle, I say 256 is equal to r squared. Taking the square root of both sides to get r by itself, the square and the square root cancel, leaving us with r equals 16. So if I ever need to solve for the radius and they give me the equation of a circle, just go ahead and set your constant equal to r squared. What is the equation of a circle with center at the origin and radius r? Well, for a circle with the center of the origin, the equation for any circle of that matter would be x squared plus y squared is equal to r squared. Because again, if I plug it into our normal equation, the zeros I can just drop, and so I'd be left with just x squared plus y squared equals r squared. All right, let's go ahead and try out a couple sample problems. Our first sample problem, we want to graph x squared plus y squared equals 49. So just looking at this, I want to solve for my radius first. So I can go ahead and say that r squared is equal to 49, which gives us a radius of 7. So to graph that, the first thing that I'm going to do is I'm going to graph points on my axes. If I know my radius is 7 and my center is 0, 0, then from my origin, I'm going to go ahead and move up 7 and create a point. So here's 7, here's 7, -7, and -7. But all of these are 7 units in distance from the center, 0, 0. So I can go ahead and draw my circle from here. And again, our center is 0, 0. We already said that our radius would be equal to 7 from r squared is equal to 49. Next, they ask us, does the point 4, 5 lie on the circle? If not, where is it? So if I graph the point 4, 5, it's right here, we can see that it is not on the circle, but rather inside the circle. And you'll be asked multiple questions like this down the road. Is it on the circle, inside the circle, or outside the circle? And if the case is where we plot the point and we see that's very clearly inside the circle, I can just say it's inside the circle. But if it's a little bit more close, then what we would do is I'd take 4 and I'd plug it in for x. I'd take 5 and I'd plug it in for y, and I'd see if it's true. If 4 squared plus 5 squared equaled 49. So let's go ahead and try that out. 4 squared plus 5 squared equals 49. That'd leave me with 16 plus 25 equals 49. Which leaves me with 41 equals 45. Which obviously 41 does not equal 45. 41 is less than 45. And if we get an answer that is less than, that means that we are inside the circle. What do you think would happen if we got an answer that was greater than? If when we plugged in our x values, they were greater than our radius. Well, that would mean that the point lies outside the circle. And if we get an answer that is equal to, if I got 45 equaled 45, well, then that would mean that they are on the circle, that the point lies on the circle itself. So those are the 3 situations that we can see. Less than is inside, greater than is outside, equal is on the circle. And again, that's just all in relation to points and where they lie in relation to a circle given the equation of a circle. Let's go ahead and try out another one. Let me go ahead and clear that out once again. But again, this is just the equation that we just went through, so you can see that we got the same exact answer. All right, next up, x squared plus y squared equals 64. So again, let's first start by solving for the radius of the circle. Well, if radius squared equals 64, the square root of 64 gives me 8. So start off, I graph points at -8 and +8 on the axes of my Cartesian plane. Once I have those points labeled, I messed up a couple of them. Here's one of them that I messed up. Once I have those points, I can go ahead and draw my circle going through all 4 points. We already said that our radius was equal to 8. And next, we're going to go ahead and check for these points, where they lie at in relation to the circle. So starting with the point -4, 7. If I want to check and see if that falls within the circle, I'm going to go ahead and plug these values in for x and y. Plugging in the point -4, 7 for x and y, I'm left with -4 squared plus 7 squared equals 64. -4 gives me 16, 7 squared gives me 49, and that's still set equal to 64. Well, 16 plus 49 isn't 64, but it's 65. And we know that 65 is not equal to 64. 65 is greater than 64. And as a result, that means that the point -4, 7 lies outside the circle. Testing the point 0, 8, well, again, that'd just be this point right down here, 0, 8. And let me go ahead and graph the point -4, 7 so that we can see that one as well. -4, 7 is right here. And as we can see with -4, 7, that looks like it's almost perfectly on the circle. But that's because it's so close to it. It isn't on the circle, it's just outside, barely. But again, barely is enough for us to say that's outside. So be very careful with those so you don't make that little mistake there. If I want to check the point 0, 8, I can do the same thing, or I can say, oh, the radius is 8 and the center is 0, 0. Therefore, of course, that would be on the circle. But just so that we can see that pattern, I'm going to go ahead and plug in those values for x and y. I'd be left with 0 squared plus -8 squared equals 64. 0 squared is 0, -8 squared is 64, and we'd be left with 64 equals 64, which of course is a true statement, which means that it lies on the circle. So again, that is two different ways that you can solve for these. Either you can graph the point very clearly and see where it lies, but if it's super close, then you need to go ahead and plug in your values and check. All right, let's go ahead and continue on. I'm going to go ahead and move past this. And again, you can always check and see with Pythagorean's theorem. You can always plug in those values. But again, that's the same exact thing as just plugging back in for x and y. And typically I'd say plug in for x and y more so than check for Pythagorean's theorem, because as soon as our center is no longer at the origin, it's going to move around a little bit more so, and it'd make more sense to plug into the equation. So plug into the equation if possible. That leads us to our second part of today's lesson, factoring by completing the square. Now this is review for Algebra 2, but it's also review for Algebra 1. And further, it's meant to make sure to help you guys out and make sure that you guys are ready for the AZM2 and also for 8.11, which is going to be using these tools. So let's go ahead and begin. Our first one that we're going to do is we're going to do x squared plus 8x minus 20 equals 0. Let me go ahead and get rid of this red dot there. There we go. So our first step. Step 1, isolate all of the x variables on one side of the equation. So the first thing I do is I add 20 to both sides. Leaves me with x squared plus 8x plus blank equals 20. Make sure that you leave a space here. Next, I'm going to find out our new c value. I need to find a new number to place here. And in order to do that, I'm going to go ahead and use the equation b over 2 squared. That will get me my new c value. So I take my b value, I take half of 8, which is 4, and squaring 4 gets me 16. So I find out b over 2 squared is equal to 16. Again, our b value will always be the value attached to the variable x. Next, I'm going to go ahead and add my b over 2 squared value to both sides of my equation. What I do to one side, I must do to the other. That'll leave me with x squared plus 8x plus 16 equals 36. Next up, step 4, I'm going to go ahead and factor the perfect square trinomial. So on the left side, we have this perfect square trinomial over here. We're going to go ahead and factor this out. So I take my a value and I multiply it by my c value. 1 times 16 gives me 16. And I look for numbers that add to be our middle term, 8, and multiply to be positive 16. Well, two numbers that add to be 8 and multiply to be 16, having all of them listed here, we have positive 4 and positive 4. 4 plus 4 is 8, and 4 times 4 is 16. So therefore, I can put those in my double bubble. Just want to take a second so that you note that when you take half of your b value, that got us 4. And then both the numbers that we're taking right now are also 4. This is a pattern that I hope that you'll notice. From here, I put both of these values of 4 into my double bubble, leaving me with x plus 4 times x plus 4 equals 36. Again, I just brought down that 36. Now, these are two of the same thing that are being multiplied by each other, so I can just bring them into one and say that that is equal to x plus 4 squared equals 36. So again, two things that are being multiplied that are the same thing, I can just say that they are being squared. Now, this is what we're looking for, because once we get into this situation, this looks very similar to the x value for the center of our circle. Remember, that's x minus the center of our circle, so the x center, squared, which is exactly what we're looking for. So this is our main purpose of doing this, so that we can get our equations like this, so that we can find the center of a circle. And we'll be covering this a lot more on Thursday in our next lesson, but again, that's why we're doing this, so that we can get to this point. So the main thing is that you know all of this up to here. If you can get here, then you should be able to do 8.11 for any circle after this. Now, once that I have this set up, I'm going to go ahead and continue this problem by solving for x. Typically, we would be done when we're doing equations of circles with this, but since we're just solving, we're going to go ahead and solve all the way. So step 6, we're going to solve for x. To do that, I'm going to take the square root of both sides. That leaves me with x plus 4 equals plus or minus 6. I can then set up my two equations. X plus 4 equals 6. X plus 4 equals negative 6. Subtracting 4 from both sides, positive 6 minus 4 equals 2. Negative 6 minus 4 equals negative 10. So x is equal to 2 and negative 10. Let's go ahead and try out another. X squared minus 10x minus 75 equals 0. Step number 1. Add 75 to both sides of your equation so that you can isolate the x values. Leaves us with x squared minus 10x plus blank equals 75. Step 2. Find your new c value. Take half of your b value and square it. Half of negative 10 is negative 5. Negative 5 squared is positive 25. Don't forget, there's a shortcut right here. This will allow you to skip steps right here. From here, I'm going to go ahead and add that 25 to both sides of my equation. Leave me with x squared minus 10x plus 25 equals 100. At this point, we're going to go ahead and factor the perfect square trinomial on the left side of our equation. And I can do that by finding numbers that add to be negative 10 and multiply to be positive 25. Those two numbers, well, we found them earlier. It's negative 5 and negative 5. Negative 5 plus negative 5 is negative 10. Negative 5 times negative 5 is positive 25. So therefore, I now set up my double bubbles. I have x minus 5 times x minus 5 equals 100. Simplifying it down, we can say that x minus 5 times x minus 5 equals 100 will be simplified to x minus 5 squared equals 100. Now again, this is what we want to get to. This is what we should be able to get to normally. At this point, I'm going to go ahead and solve for x. I can do that by taking the square root of both sides, leaving me with two equations. X minus 5 equals positive 10, and x minus 5 equals negative 10. From here, I can go ahead and solve both of these equations by adding 5 to both sides. Positive 10 plus 5 leaves me with 15. Negative 10 plus 5 leaves me with negative 5. So x is equal to 15, and x is equal to negative 5. All right, our final question of the day, x squared plus 12x minus 45 equals 0. Go ahead, try this one out on your own. Pause the video if you'd like. I'll be playing through all of it as soon as you're done pausing it. All right, trying this one out on our own. If we were to do it, the first thing that we do is add 45 to both sides to get x squared by itself. We leave a blank spot open so that we can find our new c value using the equation b over 2 squared. Well, if our b value is 12, half of 12 is 6, and 6 squared is 36. I then add that 36 to both sides of my equation. That leaves me with x squared plus 12x plus 36 equals 81. From here, I find numbers that add to be 12 and multiply to be 36. We found those two numbers earlier with our shortcut, and they both turned out to be positive 6. 6 plus 6 is 12. 6 times 6 is 36. So again, those are two terms, and our shortcut can be found right here. From here, I place them in my double bubbles. X plus 6 times x plus 6 equals 81. Simplifying down our two binomials will give us x plus 6 squared equals 81. From here, I go ahead and I solve for x by taking the square root of both sides. X plus 6 equals plus or minus 9. Positive 9 minus 6 will equal 3. Negative 9 minus 6 will equal negative 15. So x is equal to 3, and x is equal to negative 15. Again, guys, we'll be using this to help us further our equations of circles come Thursday. Thank you guys so much for watching today. If you have any questions, please let me know.